Hello everyone. So we have had some discussion on NLP in our classes, offline classes. We will today study a few more concepts regarding NLP. So we have discussed what is a token. Okay. So token is basically a unit of analysis. So token can be a character, token can be a word. Not just that, token can also be multiple words. For example, you can have bigrams. Bigrams means two consecutive words you consider as a token, or you can have trigrams, or in general you can have n-grams. So why these are needed? Because sometimes for getting an essence of the data, considering two or three words of the two, three or sometimes even more words together is more important. For example, when I have a sentence like I do not like mangoes. Okay. So if I focus on single words, then it might be slightly misleading because the word like is there. So if you try to compute how many positive words are there, you might end up saying that okay, like is there, so the person likes mangoes. But when you focus on bigrams, you realize that you have something like not like, which is opposite of liking. Okay? Hence people have introduced bigrams. So for this sentence, bigrams will be I do is first bigram, do not is second bigram, not like is third bigram, and like mangoes is fourth bigram. Okay? So for a sentence with 5 words, I will have 4 bigrams. Trigrams will be I do not, that will be first trigram, do not like will be second trigram, not like mangoes will be third trigram. Okay? So in this way, we can analyze multiple words together by considering them as tokens. Now, another important concept is stop words. So, when I want to analyze uh, text to determine, for example, something like topic, then some words may be completely useless. For example, words like is, are, be, they have no contribution in the topic. So these need not be analyzed. Their frequencies could be ignored. So these are known as stop words. So stop words are the words which are going to be present as auxiliary words just to complete the text, but they don't add much new meaning to the text. Okay? So one of the important steps in pre-processing in the case of NLP is to remove stop words. Okay? And there are standard lists available containing stop words in English, and even for many Indian languages the lists are available. Of course, for Indian languages the lists are not complete, but they are there. They are present. So you could use those. So stop word removal is one important step. Now, when you are doing analysis for say an Indian language and you want to decide which words are stop words, and especially in that particular context, because sometimes some words may be stop words uh, when restricted to that domain, they may not be stop words otherwise. Okay. For example, if you are trying to do topic allocation within statistics documents, so you have statistics documents, and within that you have to do topic allocation, like which are documents related to inference, which are documents related to say stochastic processes, which are documents related to multivariate analysis, and so on. So in this case, a random variable could be a stop word, because almost every subject is going to have this phrase random variable. So this phrase has no contribution to the topic, hence it is a stop word in that particular context. So if you want to decide which words are useful and which words are unimportant in the given collection of documents, we compute what is known as TF-IDF for every token. Okay. What is TF-IDF? It stands for term frequency. TF stands for term frequency and IDF stands for inverse document frequency. Okay, inverse document frequency. What does it mean? Let me take an example. So I have two documents. first document contains a sentence, Ram goes to school, and this is the only sentence in that document. So the document consists of only one sentence, and second is Ram eats mangoes. Now if I look at these two documents, first we compute frequencies of tokens. So let me consider token as a word. So term frequency for a particular token T is number of times T occurs in the entire text divided by total number of tokens. Total number of tokens. For example, here term frequency for the word Ram would be, it is occurring 2 times out of 1, 2, 3, 4, 5, 6, 7 words. So 2 by 7. This is because I am considering word as a token. Okay, you could consider character as a token and then things will change. So term frequency for Ram is 2 by 7, and for all the other words it is 1 by 7 because all the other words are occurring only once. So the word Ram will get more importance if I consider only term frequencies. But now you can see here, if I want to do something like topic detection, the word Ram is present in both the documents. So it is actually not useful in discriminating between the two documents. Okay. Hence, people have invented the concept of IDF, that is inverse document frequency. Inverse document frequency is log of something. Log of what? As the name suggests, it has to be inverse. So log of total number of documents divided by, so IDF for a term T is log of total number of documents divided by number of documents containing T. Okay, divided by number of documents containing T. So if I consider IDF for Ram, then it will be log of 2, because total number of documents is 2, divided by number of documents containing Ram is also 2. So this will actually be 0. So IDF being 0 tells me that ideally in the current context the word Ram has no significance because it is present in both. So it is not adding any new knowledge. Okay. On the other hand, IDF for every other word, for example IDF for goes, will be log of 2 by 1. Okay. So when we want to consider importance of any term, we consider both TF and IDF. So we worry about individual frequency as well as how common it is across the documents. So we consider TF IDF means TF IDF means TF into IDF. Hence, for the word Ram, TF IDF will be 0 and this word will have no importance. Okay. So one way of creating stop word list is to check for the given context, for the given corpus. Corpus is a big collection of text that you are analyzing. For the given corpus, we compute TF IDF for all the terms, all the tokens, and then those tokens which have TF IDF, those which have very low TF IDF value, they will be declared as stop words. Okay. So these are some of the other basics of NLP. So we will stop here, but try practicing computation of TF IDF for small documents. Okay. Let me stop here. Thank you.